Good day, ladies and gentlemen. Tracing nitrogen loading in freshwater ecosystems using aquatic biota. That's my master thesis with myself, Jackie here and Martin here. Now, the motivation of the study. I think we have been, since early this week, been introduced to that anthropogenic inputs and nutrient loading have degraded our aquatic systems, and this manifests itself into eutrophication that by now we have heard that we facilitate weed invasion. Now, what's the ecologists doing about this problem? In South Africa, I'm sure the freshwater ecologists will agree with me that we have the South African score system, which is now on its version 5, and which is the most commonly used biotic system rapid bioassessment. But now, according to Dickinson and Graham, they acknowledge the fact that this assessment cannot point the source of pollution and only give us the red flag results, only tells us if maybe the river is polluted or not. So now, I think for these reasons and other reasons, there's a need for a new technique that will help us identify and also trace nutrient loading in our aquatic systems. And I think one of the important things that Dave said yesterday, whenever you're looking at ecosystems, we look at as a continuum. So now this technique must also incorporate all aquatic systems that we have and also give us an early warning indication. Now, from what Jiggy Hill said, talked yesterday, and one of our studies, there's a potential that isotopes analysis of nitrogen will be a useful indicator for early identification. So now, what's the aims of my study? The aims of my study is to field test the application of isotopes to monitor and trace nutrient loading in freshwater systems using Duckweed Spirodela species, and also compare the results of isotopes analysis with the SAS assessments. And this is my personal favorite. Identify potential additional microinvertebrate as an indicator that will help us to monitor and trace nutrient loading in our freshwater ecosystems. The approach is take much forward for stable isotopes analysis for sigma 15 nitrogen and sigma 13 carbon, which is the heavy isotopes signals. Multiple samples were collected in two river systems, 10 sites each, 5 replicates per site. That was also accompanied by physiochemical on-site variables, and comprehensive SAS assessment was done seasonally on every site to determine the river health and so as the water quality of every site. And also micronutrient analysis was sent to BAM labs in Cape Town to just give us a round figure of what's happening there. So this study was set to run for 30 months from August last year till August this year. So currently I'm in position of my source assessment test results. I have my physiochemical variables, and now it's only on Monday that we got hold of my isotopes results. So couldn't incorporate this on my talk, so that I needed to compare this South African school system assessment results with the isotopes results. So now, what are we having out from this study? To compare and incorporate this South African school system assessment results with isotopes so that we can validate isotopes as a monitoring tool, and also identify eutrophic hotspots systems, and also potentially identify and indicate a species that will help us trace and map nutrient loading in our ecosystems, and also ultimately predict the source of nutrient pollution in our systems that will help us identify the sites of management interest like the aquatic weed invasions. They also would like to acknowledge these institutions and those individuals for helping this study.